All right, hello. Math 10. We're going to solve question 3b together. I know that some of this trigonometry stuff has been kind of confusing. So let's take a look and see if we can't make it make more sense. So here's a triangle, and yeah, trigonometry is all about finding sort of the different measures of a triangle. And so we are given a few pieces of information. We are given a side length here. This is one piece of information. We know this side length is 9. We know this one is 5. And we don't know anything else. That's all we got. So how are we going to solve this problem? So I guess the first thing I would do is think about what are our ratios. So I would just maybe keep this acronym on hand in your mind. It's the SOHCAHTOA. Many generations of students have learned SOHCAHTOA, which is just going to help us remember what the trigonometric ratios are. So the gives us, sine, which equals, I should put, there's an angle of some kind in here. Usually they like the Greek letters in trigonometry, not going to lie. They love them Greek letters. So that's a theta. It just means like an angle is equal to the opposite over hypotenuse. That's where the S-O-H comes from. S is for sine, O for opposite, H for hypotenuse. Cosine is the ratio of the adjacent side over the hypotenuse, and tangent is the ratio of the opposite side to the adjacent side. So that's sort of our different things. And you can can you see how like this is designed to help you keep that fresh in your mind? That's the story. So what do we do with all this stuff? So we can use these relationships between the different sides to find one of the sides or find one of the angles. And you just got to kind of see which ones do we have. So what I'd like to find is one of these things, one of these, either the sine or the cosine or the tangent, where I have two of the three pieces of information. Either I have an angle and one of the sides, or I have two of the sides. So let's take a look and see. So I don't have any angles, so I'm looking for two sides that are be connected. By the way, this side here opposite from the 90 degrees, that one has to be the hypotenuse. The hypotenuse. That one's got to be it. So the 9 and the 5 can be either the adjacent or the opposite, depending on whether I'm looking from alpha, this angle here, or whether I'm looking at beta. So that's going to sort of change things. But Z here is always going to be the hypotenuse. So what do we do? What's the plan? So I'm going to maybe start with alpha and see if I have sort of anything that's going to give me, looks like I have this over here. This is the opposite side. And then this side here is going to be our adjacent side. So there's two pieces of information. I have the opposite and the adjacent. So that means I can find angle alpha. So I would use the tangent ratio to do so. So let's do that. I'm going to do that calculation. So I'm going to put down my equations to say, tan theta equals the opposite over adjacent. That's just the definition of that. Oh, my J and my D got tangled up there. So then I can fill in the information I have. So I have no angle, but I do have the ratio. So I have the opposite, 5, and the adjacent side, 9. So since I have the entire ratio, I can effectively look up what the angle is. That's sort of what trigonometry is all about. This is an ancient mathematics where people noticed these properties that triangles have. And so if I know the ratio, there's only one angle that corresponds to that. If this was ancient times, you would probably look that up on a clay tablet. You'd be like, oh, well, I got 5 over 9. Let's go look at these many clay tablets. But you got a calculator, so you can just look it up on your calculator. So what I can do is I can type in 5 divided by 9. 5 divided by 9 equals. So that's a fun one. Didn't actually expect that to come out. That's pretty cool. And then I can take the inverse tan of that to sort of look up what angle has that ratio? So I'll go to second function, tangent. And so I get 29.505. I think I'm supposed to do it to the nearest single decimal place. So I can put that in there. So that's basically going to be my angle. I shouldn't have, I kind of in hindsight regret having written this. It should have been alpha. That should have been what I was talking about there. So I apologize for putting in the wrong thing. But yeah, what's that number? It's 29.1, I guess, because it's going to round up. So 29.1. So that's alpha. Okay, woohoo. Hey, once you have one of the angles, by the way, I'll erase some of this stuff. I think I will. Will I? Yeah, sure. Once you have one of the angles, so I know this is now 29.1, I can find the other angle really easily because it turns out in a triangle, all the angles add up to 180. I already got 90. I already got 29.1, so I just need to subtract all that stuff. And I actually don't have to worry about the 90 too much because half of 180 is 90, so I've already used up 90. So I'll just do 90 minus 29.1 to get what that angle is, 60.9. Awesome. I guess I probably could have done that one in my head, but who's got time for that? So there you go. Okay, so now we're doing pretty good. So we just got one left to do, and what are we going to do? I mean, there's so many possibilities at this point. We have an angle, and we have many sides, so we could just go with a trigonometric ratio. So let's do that. Let's work from alpha still, and we're looking for hypotenuse. So we have this. We have 29.1. So we have this piece of information, and we could probably find a ratio here where I could get hypotenuse in it, and another piece of information I know, and go from there. See how we could actually use sine here. Sine would work because I have the angle and I have the hypotenuse, so then I could just solve for opposite. I could even use cosine here. I could do the adjacent side, I got that, and I got the angle, so I could solve for hypotenuse that way. The only one I can't use in this case, I can't use tangent in this one because there's no hypotenuse in here. So I'm looking for the hypotenuse, so I want to find a ratio that has hypotenuse in it. So, sorry, tangent, no good. So which one should we use? Let's use sine. Why not? So sine of 29.1 degrees is going to equal this ratio here of 5 over the hypotenuse. I guess they're using the letter Z for that, so I'll use the letter Z as well. So in order to solve for Z, I can cross multiply. So I can sort of multiply, effectively a cross multiply, by the way, is sort of like you have two fractions equal to each other. You can just put this over 1 to make it a fraction. Anything divided by 1 is itself. And so what I'll do is you could times both sides by Z. And that's going to sort of cancel out these Z's, and you'll be left with Z times sine 29.1 equals 5. And then you divide both sides by the sine 29.1 divided by sine 29.1. And sort of these cancel out. So that's great. So we're left with Z equals 5 over sine, whatever the sine ratio of 29.1 is. So you might have noticed we could have done the cross multiply thing where we just sort of, we multiply across. That's why cross multiplying works, by the way. But that's fine. And now we can just punch this into our calculator. So we have, let's see, 5 divided by 29.1. And now this time we're doing sine. We're not doing inverse sine because we have the angle and we're looking for the ratio. So that's where if we have the angle, we use just regular sine. If we have the ratio, we use inverse sine. So I'll take the sine of that, and then it's divided by that. So the answer is 10.2. Seems pretty reasonable. Let's see, 10.28, so 10.3, I guess. So 10.3 is what that works out to be. So I scroll up, that's 10.3. So yeah, there you go. Trigonometry. I think one of the best things when you're searching for how to solve a particular question, it's fantastic to look at your various ratios, consider what they are, and think about ones that you have two pieces of information, whether it's two sides or a side and an angle, and then that's the one to use. That's going to help you move forward. Sometimes you have more than one option, in which case it doesn't matter which one you use. You can use either one. So that's how I solved question B. I hope that helps a lot. And if it doesn't, then keep on asking. And I appreciate your questions oh so very much. So please keep them coming. And I hope that hope it all goes well. Okay, bye everybody.